Welcome to our next talk, which will be held by Martin Gerhard Loschwitz, and it's all about what's next in Ceph. Have fun.
Thank you very much. Let's just sit down, everybody. Welcome to this presentation. Thank you for being here today. Just in case I'm speaking too quickly, that tends to happen from time to time, and in that case, please just throw something after me or raise your hand and let me know I'm speaking too fast. Don't kill me for that matter. That would be rather counterproductive for the rest of this presentation. Who am I? Please allow me to introduce myself. My name is Martin Gerhard Loschwitz, and I actually am not here at the OSDC for the first time. Thanks once again to the wonderful team of Netways for organizing this event. It's a pleasure like every year. I am living, and I've been living for the last 8 years in the beautiful capital of Austria, in Vienna. But if you heard me speak German during the last days, you will definitely have realized that I was not born in Austria. I was born in a very small city very close to the Dutch border in the very, very deep western part of Germany. You may have seen some articles written by me. I tend to write articles for newspapers fairly regularly, so Linux Magazine, Admin Magazine. You may have seen some articles by me scrolling by there. I'm a Debian developer, so if you are using Debian or Ubuntu and you run Pacemaker or ChorusSync, then you will most likely have used packages that went through my hands, because these are the packages that I maintain. You will by now probably have found out that I'm doing stuff with Pacemaker, so the high availability stack on Linux, and I tend to speak rather regularly at conferences. My famous hobby is this one, and just in case you're in Vienna, please stop by and ask me for a beer and to play a bit of bowling. I also said this the last year, by the way. I said exactly the same thing last year, and nobody of you ever rang me or got in touch with me. So not sure it's me or the game. I will blame it on the game, I guess. But for now, if you're in Vienna, then we might be able to combine this with key signing, so just stop by. If between all my free time activities, I manage to do some work, I do it for this company. We are doing 3 things mostly. Linux and high availability is one of them. We're doing OpenStack a lot these days, and we're doing Ceph. We're doing things with Ceph, we're doing installations for Ceph, and after all, that is why I'm here today. When we talk about Ceph and what's new in Ceph, I guess one of the most important things to do is to make sure that we are all on the same page with regards to the knowledge that's associated with Ceph. And for that reason, what I'm going to do in the first part of this presentation is I'm just going to give you a quick insight into how exactly works Ceph, to make sure that we all are on the same level with regards to the knowledge, because actually, in order to understand what the new features in Ceph will be bringing, it's important to understand how the thing works in the background, and how it's designed, how the solution is made, and why exactly changes are happening the way they will be happening in the future. So after all, Ceph is an object store. It's a solution that allows you to create seamlessly scalable storage devices. Why do you need that? Because we're building scale-out solutions by now. Every component we have in data centers is expected to scale out, and of course that applies to storage as well. Object stores are special when it comes to scaling out stuff, basically because they organize themselves mainly on the level of an object layer that is added on top of file systems and on hard disks. Of course, even object stores need conventional storage devices, such as normal hard disks with file systems on them. But the main difference between Ceph, or between object stores in general, and conventional storage mechanisms is that they use objects and they organize themselves exclusively based on these objects. So in fact, the borders of my hard disks and the borders implied upon the installation by any type of storage device that's underlying on the whole solution, in fact, are irrelevant. Ceph by now is probably the most famous object storage solution that we find out there. In fact, it's something that's sucking up most of the public attention right now. Although we have other solutions, most notably there's OpenStack Swift, which shares some very basic design elements with Ceph. We have other distributed storage solutions, such as btrfs, which in fact is not an object store. By now, Ceph definitely is the one that's gaining a lot of attention from the community. We'll be talking about the community in a minute. Basically, Ceph, so to speak, is what people mostly associate with the category of object stores these days. The name ceph derives from the animal family of the cephalopodi. As I studied Roman Catholic theology for 3 years, I had to learn ancient Greek. And that is why I know what that means. Cephas is ancient Greek for the head, and podos is ancient Greek for the feet. So in fact, these guys are called head feeders. And if you take a look at them, then you will know why that's the case, because basically they don't have anything except for head and feet. And so the name is quite appropriate. And by the way, also the individual ceph releases are named after subcategories of this animal family. By now they are running out of matching family names though, so they are continuously busy looking for releases for the next releases. As we will see, ceph is a solution that splits into a number of different parts. The object store, we have a block device interface, we have a file system interface, and we have a RESTful API, allowing me to access my ceph cluster just like I could access any web-based service using a RESTful protocol and HTTP. The most important component, though, is Rados. Rados is the storage engine that's running in the background. Rados is what actually takes care of storing information that is uploaded into the cluster. In fact, every information uploaded into the cluster is converted or in fact saved as a binary object. The cool thing about binary objects is that you can just split them apart, and as long as you put them together in the same order that you have split them, you will get exactly the same result you had before the split. Rados is an acronym. If we want to explain the acronym, we best start at the end of it, because that's fairly obvious. Rados is an object store, and OS at the end is what object store actually resembles. It's distributed, so anything that's stored inside Rados will be stored in a distributed way. It's not going to be in the same place, it's going to be in different places. We're talking about autonomic. In this case, what's meant here is that Rados is in fact self-administering. Whatever it can do to get itself out of trouble, to recover from the failure of individual components, is something that Rados will do, and it's not going to require the administrator to do that unless a failure, a problem is so critical that it cannot self-heal anymore. Self-healing is a very important part of the ceph concept, of the Rados concept, and that is what the A, the autonomic, stands for. And then there's redundant. Redundancy means that everything that's stored inside ceph is stored in a redundant manner and is stored at least 2 times, maybe even more. This is going to be very important for one of the really cool new features in future ceph versions, erasure coding. We'll come to that in a minute. For now, just remember that ceph takes care of redundancy internally and all on its own. In ceph, we have 2 components. One of them is the OSDs and the so-called object storage devices. Object storage devices are the data tanks inside a ceph installation. So anything you store inside ceph is going to reside on object storage devices in the end. If in the picture that we previously had, we want to paint in OSDs, we want to mark the OSDs especially, then the OSDs would basically be the hard disks together with the file systems residing on top of them. This is the layer that is going to be the host for the object layer of ceph at a later point in time. The cool thing about OSD is any storage device that can hold a file system which supports user extended attributes can become an OSD. So any type of hard disk is going to be fine. All you have to do is you need to make sure the file system on top of the storage device supports any user extended attributes supporting file system. Ceph follows the idea of unified storage, which in fact means no matter what the cluster currently looks like, and no matter what the internal cluster structure currently is, the cluster is going to expose the same interface to the outside. As long as it's functional, a client will receive all the information it needs to talk to the storage from the cluster itself. So in fact, if we take a look at this one again, it doesn't make a difference. Well, in this case, we have 7 OSDs. Or whether we can just add another 7 OSDs, we could in fact add an unlimited number of storage devices, and we will still have a working cluster. We can scale this out at ease. At any time, we can add storage devices in whatever amount we want to be added. And it doesn't make a difference either how these storage devices are organized. So it's completely irrelevant if we have 7 servers with matching amounts of OSDs, like in this case, we have 2 OSDs per server, or if we have 4 servers only and we have uneven numbers of OSDs inside the machines that we run. For ceph, it doesn't make a difference. It's exposing the same interface to the outside, and what's happening internally really doesn't matter for the client. It's actually completely irrelevant. The second component in ceph are monitoring servers. Monitoring servers do have 3 important tasks. The first important task is they monitor the health of the cluster and they enforce quorum by applying a Paxos algorithm. So in fact, if your cluster breaks apart, because one part of your cluster is losing the connection to the other part of the cluster, you will have monitoring service making sure that only one of these two parts, only one of these two partitions of the cluster can be used. Quorum in Ceph is reached as soon as one partition has 50% plus one complete monitoring server present in the installation. Any cluster partition that has less monitoring service is going to be dysfunctional and will refuse to write or to read information. So in fact, if we paint them in here, they are aside of the OSDs, they're doing quorum enforcement. And in addition to that, what they also do is they take record of currently existing OSDs. So they create a record of what OSDs the cluster has. They create a record of what monitoring service the cluster has. And they take record of the metadata service that we have present in Ceph. Metadata service are required for ceph-fs, for the POSIX-compatible file system. I'll be on that in a minute. But in fact, all these records are up to the monitoring service, so they have to do that. And the very important task is they have to serve these directories, these records of OSDs and mons and metadata service to the clients. Once a client wants to connect to Ceph, it has to talk to a monitoring server first, and based on the information it gets from the monitoring server, it will afterwards be able to talk to the OSDs directly. A client can never talk to OSDs without having talked to monitoring servers prior to that. Data placement in Ceph works fairly easy. Down here we have 4 OSDs. There is a shadow on these. I'll just make that disappear in a minute, and I'll explain why it's there. We have monitoring service, and now let's assume we have a client. And the client wants to upload something into the cluster. And as already said, before it can talk to storage devices, it needs to talk to monitoring servers. So that is what it's going to do in the beginning. It's going to talk to one monitoring server, and it will get the OSD map, the map of monitoring servers, and the map of metadata servers. And once it has these information, it knows what the structure of the cluster looks like. And now, based on the actual process it has to do, storing the file it needs to store on the service, it will start using an algorithm that was specifically created for Ceph, and it will do a number of different steps. Let's assume, for the sake of simplicity, that the file here that we are expecting to upload into the cluster is 16 megabytes large, which in fact is 4 times the default maximum object size. So in fact, the Ceph cluster is going to split this 16 megabytes large file. The client is going to split this file into 4 binary objects. And in the second step, it will assign these binary objects to individual groups. In this case, let's assume it assigns them to 2 different groups, the green one and the blue one. These groups in Ceph have a special name. They are referred to as placement groups. Placement groups basically decide what OSDs, what storage devices individual objects get to be stored on based on their relation to a placement group. Every binary object that belongs to the blue placement group is going to be on the same OSD as all other objects belonging to the blue placement group. And for the green placement group, it's the same. Now let's assume we have the calculation happening, and the client determines that based on the information it has received from the monitoring service, the green placement group is going to be on the first OSD, and the blue is going to be on the third OSD. What happens now is the client just starts uploading. And the cool thing about this is that it's going to upload stuff in parallel mode. So in fact, it's going to upload as many objects as it can at the same time. Now, of course, this is a very, very easy and very simple example. In typical Ceph installations, you will have hundreds of different disks, and you will have one file be split into a large number of binary objects, which means that, in fact, the client will start uploading many, many binary objects to different disks at the same time. And that's important because it's happening in a parallelized way. So in fact, what the client is doing is writing to a number of different spindles at the same time, which is important because obviously I can combine the performance delivered by individual OSDs, and that's why I don't need expensive hard disks. I don't need SAS drives for this. I can do it using serial data disks. And it's very common in Ceph clusters to just use 4 OSDs, standard serial data disks, with 7,200 rotations per minute, because the performance they can deliver on their own is not that large, but the performance they can deliver as a group is in this case more than sufficient, and probably bigger than the performance you can get by using individual single SAS disks, for instance. Once the client is done uploading, we have a picture that looks like this. We have a green placement group, which is on the first OSD. We have a blue placement group here, which is on the third OSD. And now I was talking about replication earlier. This is not replicated. In fact, if we lose the first or the third OSD, they would be gone and we would lose the data. So in fact, we need a step in the process that takes care of replicating stuff in the background. One way to do that would be have the client upload the same binary objects once again on the other OSDs. But that means the client would basically be uploading stuff 3 times, which causes a huge read and write load on the client. And that is why the Ceph developers have basically just decided to do it differently. You will actually typically find Ceph clusters where the OSDs are combined with fed links, so 10 GE at least, probably more. And the replication of binary objects will happen in the background. So as soon as a Ceph OSD realizes that it has been uploaded, a binary object, it will start replicating and it will start using the same algorithm the client has used previously to determine which OSDs are going to hold the replicas of the original binary objects uploaded by the client. And then they will just do the uploads. In the end, we have something that is very similar to this. We have 2 green placement groups here, 2 placement groups blue. And they are on different OSDs. We have replicas of the objects, and in this case, everything has just worked the way it's expected to work. Now, let's take a quick look back at what actually we want to have here. Basically, because I was talking about an algorithm, and I need to mention what that algorithm is. That algorithm basically is referred to as crush. It was written specifically for Ceph. It was designed by the same guy who designed the Ceph cluster itself. It was written by Sagewell. And some of you may think it's a bad idea to call an algorithm that processes data with crush, but it's just an acronym. In fact, it's the acronym for controlled replication under scalable hashing. And the general assumption about crush is that it's going to be a random algorithm, so it's going to produce random results. But as long as the layout of the cluster is the same, it's going to be producing the same random results reproducibly, which means that if I'm uploading an object into the cluster and I do the same calculation later for reading that object, I will get exactly the same results I got in the first place. Only once the cluster layout changes, because I lose OSDs, because OSDs fail, or because new OSDs are added, the result of the calculation using the crush algorithm is going to change. The cool thing about crush is that you can configure several parameters related to crush. And by doing that, you can make the cluster rack aware, which means that you can basically tell Ceph, hey, store 1 binary copy of the object in rack 1, and store the other one in rack 2, which may be in another fire protection zone inside your data center. So that's cool stuff. But in fact, it's not quite there yet where the Inktank developers want it to be. Interface-wise, we are talking about 3 different interfaces here. The Radar's block device allows to access a Ceph cluster like you would access a standard block device. The Radar's gateway is the interface that provides a RESTful API. And the ceph-fs is a POSIX-compatible file system, allowing you to access a Ceph cluster like any POSIX-compatible file system that you know. And those who were in my presentation last year already, of you, may think, okay, so I knew that already. This is boring. What the hell's wrong with the guy? Why is he telling me the same things he told me last year? We're done with that part now. And now let's get to the really cool things. So let's get to the stuff that actually we will see in Ceph, either in the very close future or in the future not so close, but still reachable from today's point of view. We'll be talking about some features today which will be introduced very, very quickly in Ceph. Erasure coding is one of them. Tiering is another one. We will be talking about distributed setups with Ceph, multi-DC setups. We'll be talking about automation with Puppet and Chef. We'll be talking about ceph-fs, about the POSIX-compatible file system. And we'll talk about enterprise support, and that's the part of the presentation during which I will feel like an Inktank marketing guy. But some companies do demand support for solutions like this, and they will not be allowed to introduce solutions if they cannot get enterprise support from the vendor, and that is why we'll be talking about that one really quickly. So erasure coding. Who of you has heard of the feature already? Okay. Let's jump back one step to this picture. You previously saw this one already. And as you can see here in this case, what we really have is we have a one-to-one copy of every binary object that's present in the cluster. So in fact, until now, Ceph has really worked like a RAID 1. Every binary object that you uploaded into the cluster really was a copy or would have been copied onto another place inside the cluster, but it was exactly the same binary object once and the second time on another place. Every binary object exists exactly 2 times, as you can see here. It's the same binary object, it's on 2 different OSDs. Now the problem with this approach is it works great, but it reduces the net capacity of your cluster by 50%. And that's only if you go by 1 replica. Many people want to have more replicas, so many people want to have 2 replicas or more of that, and that means they are, in fact, reducing the net capacity of their installation even more. So if you buy 80 terabyte of hard disk space, the net capacity of the cluster is going to be 40 terabytes. And this sort of, at least partially, nullifies the huge advantage we get by using Ceph, because it means we need to buy more hard disks all the time. We need to extend the cluster exponentially. And that is something that's a problem for many people, because obviously it hurts to lose 50% of the net capacity that you have. And that is where erasure coding comes in. It makes Ceph work like a RAID 5. You will all have used RAID 5 by now in your data centers. And it's a feature that actually was written by the community mostly. It was mostly developed by Loïc Dahary, who is a French developer, and I had the honor of having erasure coding explained by him to me in person. I understood about 5% of what he said, but I will still forward those part of the information that I'm sure I understood correctly. The basic idea behind erasure coding in Ceph is to split binary objects into even smaller chunks, which means that we need to adapt our example. Right now we have more OSDs, and as you can see, we have binary objects, and these are split into chunks actually. And this is a very, very simplified view, but it's going to help you understand what erasure coding actually is trying to achieve. Because basically the whole idea behind erasure coding is, as soon as one OSD fails, I'm not losing complete objects, but I'm losing individual parts of complete objects. So let's assume that one of our OSDs has failed, and now we are missing a part of the green binary object that we have seen up there. Now this is using a XOR mechanism. In fact, it's a very, very complicated XOR implementation. It actually works, which is the good part of it. What's going to happen in this case is the one OSD that didn't have anything left, or that didn't have any object until just now, is going to get information about the 2 remaining chunks we still have of that object that was gone away, and it's going to recalculate the missing parts out of the 2 objects or the 2 chunks of the binary object it still has. So in fact, based on this assumption, it's going to recreate the missing part, and it's going to have the missing part afterwards. The cool thing about erasure coding is this reduces the amount of space required for replicas enormously. It's configurable. I can basically decide what level of replication I want to have. There are different replication factors available, so I can basically say I want anything between a replication 1 by 1, so a 2.0 replication, to something as low as 1.2. There is one problem with this approach, or actually it's not a problem, it's more like an inherent design thing that this approach comes with, and that is the lower the level is, the lower the replication factor is, the longer it takes to recalculate missing chunks, because there will be a lot of communication happening in the background, and there will be a lot of calculation happening in the background. So in fact, the lower you have set, the lower the value is you have set for the replication factor, the longer a recovery of a failed OSD is going to take, but the less space you are going to lose by having replicas inside your cluster. I think the standard value is something between 1.5 or 1.7, so it's still better than a complete replication, a 1.1 replication, a 1.2.1 replication. Really, there is no golden standard on what the replication factors should be that you will be using. You will probably have to test out based on the environment that you have and based on the hardware that's available in your setup. Erasure coding is going to be available in Ceph 1.80, and that's the version that actually should have been released 4 weeks ago. You're very happy because I was under the expectation that the thing I would be talking about would be released about 4 weeks ago, but in fact it's not yet. And so this is going to be a brand new feature in the next and upcoming Ceph version. There's tiering. Tiering is a very important factor because in fact not all data stored inside a Ceph cluster is equal. And if you've been dealing with storage up to this point, then you will have made the same experience. For instance, stuff that is uploaded, that has just been uploaded to the cluster very recently, is usually expected to be served quickly because it's hot. So anything that I upload into the cluster, I typically want to make available to others immediately, and others will expect this information to be served almost as soon as possible, almost immediately. And on the other hand, I may have customers willing to accept slower performance in exchange for lower prices, which means I would basically have to put those customers onto slower storage. I would have to pay less for acquiring the storage. I would be able to charge my customers less, but in fact, it would still be something that they would be willing to accept because they get lower prices. In Ceph, up to this point, tiering was partially there, but it was hard to implement a working system of different tiering mechanisms because there are a number of limitations. With Ceph 0.80, pools will allow to store data on different hardware based on the performance the hardware can deliver. This has personally been present in Ceph up to now already because we were able to do very similar things using the crash mechanism and configuring the crash mechanism accordingly. The important thing here really is pools, and you may not have heard of pools just yet. So what are pools? Pools in Ceph are a logical unit, or actually they are a logical unit in the Radar's object store, so in the storage engine that's running in the background. A pool is a bunch of placement groups. So whenever you're talking about a pool, you are talking about a defined logical unit of placement groups that we have inside the cluster. And by using tiering in Ceph, pools can be tied to specific hardware components. I can basically say there is a pool that's named fast, and that's residing on SSDs only. And I can have a pool that's called medium, and that's residing on serial ADA disks. And I can have a pool that can be very slow. For instance, archive storage is something that is a typical use case for very slow storage because archives are used only very infrequently and rather seldom. So in fact, anything that's inside an archive doesn't need to be served very fast. And clients accessing it may be willing to accept longer waiting times when they access it. And now, the interesting part is that in Ceph 0.80, using pools, we can actually introduce a system that makes use of these features, that leverages these functionalities. All replication in Ceph happens intra-pool when tiering is in use. So in fact, one pool, one specific bunch of placement groups is replicated between the same pieces of hardware. And the really cool feature in Ceph 0.80 is that by now, data may be moved from one pool to another in Raiders on the fly. That's the main functionality that up to this point was missing in Ceph. Up to this point, it was not possible to move data from one pool to another. Using the tiering feature in Raiders, this is going to be different because using this feature by now, we will be able to move replicas or anything inside one pool to another on the fly inside the Ceph level. And by that, moving information that is not recent anymore onto the slower storage, in fact, is very easily possible. The feature is going to be present in Ceph 0.80 as well, in the release that's going to be codenamed Firefly, and that's due for release probably within the next 4 weeks. We are talking about multi-DC setups, and when we talk about multi-DC setups, there is one thing we need to take into consideration, we need to take into mind with regards to the history of Ceph. In fact, Ceph was started in 2004 as the PhD project of Sage Well in the University of Santa Cruz in California. And he received funding from different governmental organizations, basically the US Department of Energy. Back then, they were looking for a replacement for their Lustre cluster because Lustre for them wasn't working great anymore. They wanted a replacement to be written that would still be able to do highly performant synchronous replication. Now, the important word here is synchronous. Ceph has always been made for a use case in which synchronous replication was the basic design idea. And it's not like Ceph has always been has always had the structure it has today. In fact, some of the components that we have seen in Ceph by now have been added in the aftermath. They were added by Sage to Raiders and to the Ceph suite because he realized that after he was done with the PhD project, there may be money in this project and he might have something that he could actually be turning into money. And solutions like the RESTful API or the block interface were added to Ceph only afterwards. But it was all done on the implication that Ceph would be used locally and it would be used for synchronous replication between the nodes within one data center. Now, offsite replication is typically asynchronous because I don't want to be waiting in data center 1 when doing a write request for data center 2 to have successfully received the write. Typically, the connection between two data centers is not LAN quality, and it's not local LAN quality either. And in fact, if I'm doing multi-site replication, then I will have very long latency penalties for waiting for write requests. And that's something that most customers are unwilling to accept. Exactly for that reason, it's very, very unfortunate and a very, very performance-hungry setup to create one Ceph cluster that directly spans across two data centers for exactly the reasons that I have just mentioned. You will not have LAN quality, and you will accept very high latency issues, very high latency penalties for running a Ceph cluster like this. An earlier version of Ceph, Ceph 0.67, in fact, received a feature that was called Radar's Gateway Federation. So the Radar's Gateway, the RESTful API to Ceph, was added a feature that was called Gateway Federation. And this is a first step, this was a first step on the way to working multi-DC setups in Ceph and Radars. Down here we have two data centers. We have one data center that's on the right. We have one data center on the left, DC1, DC2. And the idea behind federation in the Radar's Gateway basically is that I have Radar's Gateway instances on both sides of my cluster, and there is an additional piece of software that's called sync agent. And this sync agent basically recognizes objects configured for replication by the user, and it will basically sync them from one data center to the other in the background. So in fact, by using the sync agent together with the Radar's Gateway Federation feature, what I can do is I can add the asynchronous replication capability to the Radar storage cluster, in fact, without having to modify Radars itself. Now, the problem with this type of integration is that obviously it's not very well and very tightly integrated into the Ceph cluster. And one of the pieces of work that's ongoing and that's happening in Ceph in the background is the integration with this feature into other Ceph components, basically to allow replication of any type of information stored inside Ceph between one data center and another. There will be improvements for multi-DC installations in the next Ceph releases. Actually, there isn't a concrete roadmap on when the whole cluster will be mirrorable between two sites, but it's an item that's being worked on, and it's an item that is very high, at the very top of Inktank's to-do list. And we will see lots of movements there over the next few months, and probably within the next major releases of Ceph, there will be substantial changes with regards to how Ceph does multi-DC deployments. Now, let's talk about automation. Automation is a very important factor, and I guess some of you will be at the Puppet camp that's going to be here tomorrow. And who of you is not using automation just yet in his data center? That is very fortunate. Now, assume that you were running Ceph, you were running Puppet. Who of you is running Puppet? Okay. Let's assume that you had the plan of just deploying a Ceph cluster in your local installation, and you found out that right now there is no valid and no working integration of Ceph into Puppet. So there are no Puppet modules available, allowing you to properly run a Ceph cluster from within a Puppet installation. Who of you is using Foreman, by the way? Who's using the Puppet dashboard? Who's not using an ENC? Okay, great. Which adds another layer of complexity, because in some way we need to have Puppet modules that work with Ceph, to work with Ceph, and we need these Puppet modules to work together with the numerous ENCs that we have in Puppet and that we have available for Puppet. Now, Ceph clusters will almost always be deployed using tools for automation, because once you have reached a level of 200 Ceph storage nodes, you definitely don't want to be managing those by hand anymore. And that is why it's important for Ceph to play together well with Chef, Puppet, and Co. Basically, we want these functionalities to be inside the automation solutions, for instance, by using cookbooks for Chef, by using the appropriate modules for Puppet. And the good news for you, who's using Chef? Any Chef users? Well, okay, so, wow, wonderful. See, so good news for you, it works, actually. Chef cookbooks are maintained and provided by Inktank, so they are coming right from the upstream company doing Ceph development as well. And they just work like a charm. Basically, it's you install the cookbooks inside your Chef installation, and you run Chef, you run Knife on your target nodes, and that's it, and you will have exactly the OSD configuration that you have configured to be present inside Chef. Now, those of you using Puppet, which, as I understand, is the majority, up to this point would have had a little bit of pain with regards to Ceph. Basically, Inktank does not provide Puppet modules for Ceph deployment. So there is no Puppet module officially sponsored by Inktank or officially provided by Inktank. And if you take a look at GitHub, or if you Google for Ceph and Puppet, then you will realize that right now we have at least 6 concurring modules existing on GitHub. Some being forks of each other, some having written as much as 30 pull requests to other individual forks of the same original module. The problem with all those things is that they either don't work or work in a very limited way or miss important features. Obviously, it's important for a Puppet Ceph module to be able to deploy OSDs. Some of them don't do that. So they are very incomplete. They're not something that you want to use in your Puppet installation for everyday's business. The problem in this case really is that none of these modules uses the tools recommended by Inktank for Ceph deployment. Inktank has written a tiny little Python tool that's called Ceph Deploy. The cool thing about Ceph Deploy is that it's distribution agnostic. So all you have to do is tell Ceph Deploy install ls-mon, and it's going to deploy a monitoring server on Alice, and that's it. No matter what system Alice is running, at the end of the process, you will be having a monitoring server deployed on Alice. And none of the Ceph modules for Puppet I have previously mentioned use these functionalities. None of these modules use Ceph deploy, which basically means that you would have to re-implement the complete magic that's present inside Ceph deploy inside your Puppet module, given that Inktank has spent about a year getting Ceph deploy into a status where it's actually enterprise ready. That obviously isn't a good idea. So what can we do about this? What's the what's the glimpse here of hope that we have? There is one Puppet module that's called Puppet Ceph Deploy, and it uses that name for a reason, because obviously it uses Ceph Deploy. It was, in fact, written by a Cisco employee. I mean, who would you expect to write a Puppet module for Ceph? A Cisco employee, of course. He is, it's Donald Tolton, actually. He wrote the original version of the module for Ceph. Until 2 weeks ago, the module was using Hiera. In fact, Cisco convinced him to get rid of that dependency because many existing Puppet installations don't use Hiera, and if you want to install a module like this afterwards, you will obviously have a lot of migration work to do. Last week, the Puppet Ceph deploy module got a huge commit that basically stripped out all Hiera functionality. So in fact, the module now works nicely without having any Hiera infrastructure in place. And it was not completely done just yet. It still isn't completely done, but generally it looks very promising, and it already works. It plays together very nicely with ENCs, such as the Puppet dashboard or the Firmament project. This is the GitHub page of the actual Ceph module written by Donald Tolton, and there is one pull request available for that Ceph repository, introducing some changes and some fixes that actually I wrote. So the pull request was written by me, and last week I was able to successfully deploy a Ceph cluster with as little as 48 OSDs and monitoring servers and metadata servers using this version of the Puppet Ceph deploy module along with the modules, along with the changes that I have committed to the module. So if you want to run this software, if you want to run Ceph together with Puppet, then you definitely want to take a look into these, and you should be able to get a Ceph cluster bootstrapped with Puppet fairly easily, which in fact means if you want to use this, then probably this is the solution for Puppet that you want to go with. ceph-fs. Who has heard of ceph-fs? And who is only here because he plans to use ceph-fs? Oh, that's great. That's about 100% less than last time. Ceph-fs is like a bleeding wound inside the Ceph development community. And some people consider it already vaporware, but in fact that's not fair, because Ceph-fs is already available and it works, most of the time at least. there is one thing you need to understand about ceph-fs if you want to judge the quality of the code base that we currently have. For ceph-fs, the really critical component is the metadata server, the MDS. After all, if you have an object store and you want to deliver POSIX-compatible metadata for that object store, then you need to have a component that can deliver those metadata. And in Ceph, that's the metadata server, the MDS. In fact, running ceph-fs today with exactly one active metadata server is fine and will most likely not cause trouble. It will at least as likely cause no trouble as a standard SAN storage is going to cause trouble. So as long as you have one active MDS inside the whole installation, that's fine. Now the offer of ceph-fs and the offer of Ceph and of Rados obviously doesn't quite like that idea, because according to Sage Wild's opinion, any component inside a setup like this must be capable of proper scale out, which means that I must be able to run several active metadata server inside the same cluster, and that just has to work, which means that basically I must be able to have a number of metadata servers and they all must be able to be active at the same time. This is called dynamic subtree partitioning. Every active metadata server will be responsible for the metadata of a certain subtree of the POSIX-compatible file system. So if I want to see the metadata of one file, then I need to do that using one metadata server, and if I want to see another file in another subtree, then another metadata server will be responsible for doing that. And right now, this dynamic subtree partitioning is the part that's causing trouble. It's something that Sage really wants to get fixed, because obviously ceph-fs still is the thing that all this started with, and it's the thing in the middle of his heart. Right now, ceph-fs is not Inktank's main priority. So in fact, right now, they are not putting massive amounts of work into ceph-fs, but they are actually planning to release ceph-fs as stable in the fourth quarter of 2014, along with a new ICE version of Ceph, along with a new long-time version support. So in fact, if you want to use ceph-fs, it's coming, and they are working on it, but right now they have other things they need to do first, and once they do that, they will be featuring a ceph-fs that actually is stable. And how far that is going to have another feature or other features aside the ones that I have just mentioned, we don't know just yet. We don't know what's going to be on the roadmap for ceph-fs in 2014, but they are working on making ceph-fs stable, and it's going to happen. It's not like somebody has withdrawn the project. It's not like they're not planning to do that anymore. They just need some time for that.
Quick question.
Please.
I have no idea about that really. I want to do something with it. But if ceph-fs is not stable, that's probably not widely used. So what's the main point of Ceph at this?
Most people use it as a storage backend for object storage, mainly for distributed block storage inside virtualization environments. And most people doing that are very happy with it because that part of the cluster is fine. Many people are using the Rados gateway for RESTful access to a cluster. So basically what they do is they provide storages like Google Drive or Amazon S3 using a Ceph cluster and the Rados gateway in front of it. And yeah, I think these are the two main users right now. Enterprise support. Many companies have policies forcing them to have support contracts for major individual parts of their infrastructure. And obviously, if you're running a central Ceph storage, then in fact, that is a central part of your infrastructure. And in fact, these companies are forced to have some type of support contract, even if it's just an insurance, that in case of problems, somebody will cover the people's back. Inktank has started to offer that support through a product called Inktank Ceph Enterprise called ICE. ICE comes with a number of different features. ICE gives users long-term support for certain Ceph releases, such as Ceph 0.80. That's going to be the Ceph release that will feature long-term support. And Inktank promises to bring you hot fixes just in case you run into a problem that actually is critical for the health of your cluster or your data. So in fact, as soon as you're an ICE customer, you will receive updates for critical problems by Inktank once the problem is identified and the fix is accordingly provided. And of course, that comes along with service level agreements and all different types of things related to standard support contracts. What Inktank is doing here is very much resembling the support contracts that you can get from other companies. The Inktank Ceph Enterprise also brings Calamari, which is Inktank's Ceph graphical user interface. Here's a snapshot that of course, cannot give you an insight into what ICE and Calamari is really capable of doing, but one of the things that you obviously can do is managing your OSDs, and they are actively planning on extending the feature set of Calamari, so once you have ICE support with Inktank, you will be available to use the Calamari graphical user interface. Now, in how far that's important to you really is up to every individual person, because I know people, and probably some of you, or even many of you think likewise, who don't need graphical user interfaces, who are very satisfied with using the command line, so that's fine as well. But if you have ICE, then obviously you get Calamari. Prices are available from Inktank, so in case you want to do that, please contact Inktank directly. I really don't want to turn this into a ad session for Ceph support. Really quick glance at distribution support, because that's obviously going to be interesting for many of you as well. Inktank does a lot already to make installing Ceph on different distributions as smooth as possible, which in fact means that as of today, you can seamlessly install the complete Ceph cluster with all the components associated with it on Ubuntu 12.04, Debian, Wheezy, Red Hat Enterprise Linux 6, and /11. For the future, we have upcoming Ceph versions with added support for other systems. Ubuntu 14.04 is going to be present in Ceph 0.80, so the version that's going to be released within the next weeks. We will have Red Hat Enterprise Linux support for Enterprise Linux 7. Once RHEL 7 is released, the Inktank developers currently expect that to happen in the December of 2014. Whether that's something that Red Hat lives up to, obviously, is in the question, but if they do, then Inktank will be providing appropriate packages. What's the Ceph release schedule right now? Firefly 0.80 is the one release that I have already mostly mentioned. We have erasure coding, we have tiering, we have user quotas, and we have Ubuntu 14.04. Expected in May 2014, along with the release of the Inktank Ceph Enterprise Support 1.2. Giant is going to be a non-LTS version present in happening in summer 2014. And then there's the H release, which doesn't have a name just yet. It's going to be out in December 2014. It will actually have ICE 2.0. That's the one that will feature ceph-fs support, and that's going to include support for Red Hat Enterprise Linux 7. We have further things down the roadmap. Inktank is actively talking to VMware right now to provide a native storage backend for VMware to Ceph, which means that once that is done, you can use Ceph directly from within VMware, and you can store your virtual machines from within VMware right on a Ceph cluster. And that is something that many, many people have been asking for. I would like to point out, though, that Inktank is not the problem in this case, or at least they claim they are not. That's what I heard from them. They are working on it, and it's going to happen. It's just not going to happen right now. If you want to have more information on Ceph, Inktank does events, local information events, rather regularly. These are called Ceph Days. They are run by Inktank all over the world. The next Ceph Day is going to be in the United States. But up to this point, 2 have happened in Europe. One was in London, one was in Frankfurt in February 2014. And there's Y missing, by the way. So one was in Frankfurt in February 2014. There is going to be another one in Europe this year. There is no concrete date for that just yet, but Inktank will be announcing the date as soon as they have figured out when the next Ceph Day in Europe is going to be. So if you take a look at inktank.com/Ceph-days, you will learn about the dates of the next European Ceph Day as soon as Inktank publishes them. Ceph Days allow together with others willing to use Ceph. That's one of the main things that the Ceph Day in Frankfurt was good for. Basically, many people talking about the experiences they already had and talking about the plans they have for using Ceph. So in fact, that is something that is very, very welcome, because many people are relatively new to Ceph, and it always helps to hear experiences from others who have done something similar like you are about to do. And of course, there is a guarantee, unless he's sick or dead, that at every Ceph Day you will be able to meet Sage Wells, so the original author of Ceph, and the guy who is still controlling the complete development. And in fact, that is something very cool, because he's a very nice guy, and you could basically ask him any technical question about Ceph. If he cannot answer it, the chances somebody else can are relatively small. Which brings me to thanking him for the stuff that he has just written, and to Inktank for the allowance to use the Ceph logo. Should you want to learn more about Ceph, then don't hesitate to write me an email. You can look me up on Google+, And we are doing things with Ceph regularly, so follow us on Twitter for more information. Our website is sdexo.com, and should you want more information on Ceph, you will be able to find a lot of hints and kinks on the website, so anything related to Ceph installations. If you run into trouble, then chances are you will find the solution in the publicly available section of our website. And with that, I think we can conclude the part of the presentation and go to the questions. Yeah.
Is there any... Thanks. Just out of curiosity, is there any S3 API provider with a Ceph backend?
Yes, there is. The Radars Gateway supports the S3 protocol and the OpenStack Swift protocol.
Out of the box?
Yes.
Cool.
That's what I'm saying. He said cool just for the log.
Have you used, have you used the Kraken Dash already?
Which one?
Kraken Dash.
No.
Okay. Me
No.
also, but
That was easy. No, sorry.
has anyone used a Kraken Dash? That's a dashboard to show the health of the cluster and what your OSDs are doing.
Is that the stuff that's written by Susan? No, it's not, right?
No, no.
Okay. I must admit I haven't even heard of it up to this point.
Okay.
But I haven't used it. So to answer the question, unfortunately, no, I haven't. Further questions? We still have 9 minutes of time, so if you have any questions on Ceph, now is the time to ask them. See, just got to make people aware of the unique chance they have. I like that.
Hello. Can you tell me something about typical latencies of a Ceph storage?
Well, for a local Ceph storage, the typical latency basically is the one that's caused by a network, and added to that is the latency that's caused by the hard disk on the other end, which is the reason why many people use a trick. In Ceph, every OSD has a component that's called a journal. And in fact, it's exactly the same that you have for a file system journal. Any data that is stored onto an OSD hits the journal first. And people regularly use a mechanism in which they outsource the journal of OSDs to SSDs because they have a considerably lower latency than normal disks have, than normal Springer disks have. And using that mechanism, you can improve the speed that is actually, or you can decrease the latency that's caused by writing information into the OSD journal. In fact, a client receives an acknowledgement for writes as soon as the binary object it is uploading has hit the required number of OSD journals. So if I have a replication count of 2, if I have every object 2 times, as soon as my upload has hit the OSD journals of 2 OSDs, I'm getting the OK for the write as a client. And using SSDs, you can decrease the latency caused by your disk dramatically. If you want to decrease the disk, the latency caused by the network, that's another thing to do, obviously, but considerably harder. So the SSD trick works very well.
Okay, this brings me to the next question. You just mentioned it, how to bring down the network latency. Have you experience with using InfiniBand and especially using maybe things like RDMA?
We haven't. As far as I know, Sage has been asked this question a number of times, and it's definitely on Inktank's roadmap to figure out how exactly making Ceph work with InfiniBand better than it does right now is possible. But up to this point, there is nothing that would be production ready for this part of the installation just yet.
Okay, thank you.
But come to a Ceph day and ask Sage about it.
Will do.
Any further questions? Okay, then thank you very much, Martin.